Good day, kids! Our subject for today is science. And today, I will discuss to you about measuring motion in terms of distance and time. I am Teacher Lani. Most essential learning competencies describe the motion of an object by tracing and measuring its change in position over a period of time. This lesson, Unit 2, Number 1, elucidate the meaning of motion of an object by tracing and tracing its change in position over a period of time. Number 2, compute the movement of an object in terms of distance and time. And number 3, carry out the value of having a reference point when understanding motion. Look at the picture. Questions. Number 1, what does the children do in the picture? Number 2, do you know what do you call to the traditional Filipino game? Number 3, do you experience to play patentero with your friends? Number 4, what are you going to do in order to win in the game? Number 5, do players need to move while playing the patentero? Why is it important to move around and let the tin be fell on the ground after it was hit by the opponent player? Body movements in any games are necessary to play the game properly and of course to win. Motion and energy are relatively important in our daily life. Motion and energy work together to make things easier for us. Through the help of force, motion can be achieved. Without motion, we cannot do work and enjoy life. Life is so boring without any movement or any motion in it. Pull or push. As part of exerting force may also relative on the distance on the object when it is moved from one point to another. However, distance is the measure of how far or near 2 points are from another. It can be measured using different ways, such as time, landmark, or body parts. What is motion? Motion is a change of position with respect to its reference point. A reference point is a fixed place or an object used to determine the position of the object. Motion occurs when an object changes its position relative to a reference point. For example, you are riding in a car at 35 miles per hour. You look out of your window at a tree. The tree looks like it's moving. A dog standing beside the tree sees the moving car and starts to chase it. To the dog, the car is moving. Which object is moving? The car or the tree? Why? Mass is the property of an object that resists change in its motion. A friction, a force that resists motion created by objects rubbing together. The activities that you are going to perform will clearly describe what causes the object to move. Also, you will measure the distance covered by a moving object which is affected by its speed or the measure of how fast it moves. Letter A, prepare the materials listed. If not available, you may use other materials at home to perform the activity. You may ask the help of your parents, guardians, or any adult members of the family if needed. Title, Movement and Motion. Materials: small ball, notebook large or hardbound book, masking tape, toy car, ruler, marker pen. Procedures. Number 1. Mark a spot on the floor with a masking tape. Label it as point A. Number 2. Place the small ball on point A. Then blow on it. Number 3. Using a ruler, record the distance in centimeters if the ball moved away from point A or if it did not move at all. Number 4. Place a toy car on point A, then blow on it. As much as possible, apply the same amount of force applied on the ball. Number 5. Using a ruler, record the distance in centimeter if the toy car moved away from point A or did not move at all. Number 6. Place a notebook on point A, then blow on it with the same amount of force applied on the ball and the toy car. Number 7. Using a ruler, record the distance in centimeter if the notebook moved away from point A or did not move at all. Number 8. Repeat steps 1 to 7. Push the ball, the toy car, and the notebook with your fingers. Record your observations. Number 9. Repeat steps 1 to 7. This time, use one side of the hardbound book as a ramp. Label its highest point as A. Put the ball, toy car, and notebook one at a time without applying any force. Observe what will happen to the ball, toy car, and notebook, and record your observations. Number 10. Make a table like the one below to record your observations. Put a check mark if there was movement after force was applied. Objects to be moved: ball, toy car, notebook. Questions. Number 1. Which action causes all the objects move? Number 2. Why do you think this action causes movement? Number 3. Which among the objects is the hardest to move? Why? Number 4. Which among the objects is the easiest to move? Why? And number 5. What is the importance of point A in determining the movement of the objects? Letter A. Name at least 5 of your daily activities and describe how motion takes place. Distance. A distance is a measure of how far or near 2 points are from one another. It can be measured using different ways, such as time, landmarks, or body parts. For example, when you are going to school, the distance of the school from your house is 2 kilometers away, and you spend 1 hour of walking just to get there in your school. This may not validate that you spend less time going to school than going to church, which is far apart from the school. There are factors to be considered, like traffic or winding road, that can be affected your travel time. Therefore, there are appropriate tools and ways to measure distance so that you can tell whether the object is near or far. Distance is measured by using tools such as meter stick, tape measure, measuring wheel, and ultrasonic distance measurer. The metric system of measurement. The metric system is the world standard for measurement. It is used by scientists throughout the world. In the metric system, the standard unit of measurement used for distance or length is meter. You just add the prefix kilo when you are referring to distance is quite far. Prefixes like deci, centi, and milli. Effect of speed and time on distance. The distance covered by a moving object is affected by its speed, or the measure of how fast it moves. The faster it moves, the shorter time it takes for it to cover a certain distance. The slower it moves, the longer it takes for it to cover the same distance. Thus, in a given time, the fastest an object moves, the greater the distance that it covers. And the slower it moves, the less the distance that it covers. Speed. Speed is measured in meters per second or kilometer per hour. For instance, a tricycle drove a passenger's house that is 20 meters away from the station in 10 minutes. What is the speed of the tricycle? This is the computation. 20 meters over 10 minutes times 20 meters over 60 seconds equals 20 meters over 60 seconds equals 3.33 meter per second. On the other hand, the distance covered by a moving object is affected by speed, or the measure of how fast it moves. Speed of an object can be calculated by dividing the distance covered by an object in motion by the time spent to cover the distance. Speed equals to distance covered over time, or S equal to D over T. For example, Garros traveled 5 meters away with her bike from her house going to Plaza in 120 seconds. In getting the speed of Garros' bike, following the formula stated above, speed equals to 5 meters over 120 seconds. Speed equals to 0.42 meter per second. The speed of Garros' bike is 0.42 meter per second from her house to the plaza. Letter B. Prepare the materials listed below. If not available, you may use other materials at home to perform the activity. You may ask the help of your parents or guardians or any adult members of the family if needed. Title: Measure It. Materials: 3 books of equal thickness, marble, 2 rulers of the same size, and metric tape measure. Procedures. Number 1. Position the rulers together on a book with a distance from each other that would fit a marble. The rulers would serve as a ramp for the marbles. Number 2. Release the marble between the rulers. Measure in centimeters the distance covered by the marble. Take note of the time in seconds as the marble travels. Number 3. Repeat steps 1 and 2 for trial 2. Number 4. Put another book on top of the first book. Repeat steps 1, 2, 3. Number 5. Put another book on top of the 2 books. Repeat steps 1 to 3. And number 6. Record your measurement in the table in the next page. Number of books, trial 1, trial 2. 1 book, set up A. 2 books, set up B. 3 books, set up C. Questions. Number 1. What setup resulted to the shortest distance traveled by the marble? Why do you think the marble traveled the shortest distance with this setup? Number 2. What setup resulted to the longest distance traveled by the marble? Why do you think the marble traveled the longest distance with this setup? Number 3. How can measuring distance helps us to compare things in motion? Number 4. What is the effect of height on the distance a marble travels from a ramp? Number 5. What is the speed of the marbles in trial 1 and 2? Letter B. Analyze and solve the problems. Then, Fill in the table with the needed information. Problems. Number 1. A cyclist travels 200 kilometers in 8 hours. What is the speed of the cyclist? Number 2. A mouse runs a distance of 2 meters in 15 seconds. What is its speed? Number 3. A car travels 300 kilometers in 5 hours. What is its speed? Number 4. A man runs 108 kilometers in 3 hours. What is his speed? Number 5. A tricycle drove to a passenger's house that is 20 meters away from the station in 10 minutes. What is the speed of the tricycle? Remember that in describing the motion of an object by tracing and measuring its change in position, distance traveled over a period of time, you need to take value on the importance of having a standard unit of measurement in determining the distance between 2 points. Knowledge in conversion is also necessary to get the speed of a moving object. Can you try to solve this word problem? Learning activities. Santos family always get together during weekends. They plan go to Tagaytay with their new Toyota Rush. Tagaytay is 70 meters away from their home and they tend to get there in just 35 minutes. What will be the speed the car needed to land in Tagaytay? Write your answer on the clean sheet of paper. Read the questions and choose the letter of the best answer. Number 1. A change in an object position is called A. Force, B. Motion, C. Pulling, D. Pushing. Number 2. How do you know if an object has changed position? A. It is not visible anymore. B. It looks bigger. C. It is farther or closer from a reference point. D. It is on top of a reference point. Number 3. Forces have both A. Magnitude and speed, B. Direction and speed, C. Magnitude and direction. Number 4. The distance traveled by an object per unit time is called A. Velocity, B. Speed, C. Momentum, D. Acceleration. Number 5. The property of an object that resists change in its motion is A. Mass, B. Inertia, C. Velocity, D. Momentum. Number 6. A force that resists motion created by objects rubbing together is A. Gravity, B. Friction, C. Speed, D. Force. Number 7. A force that pulls objects toward each other is A. Force, B. Gravity, C. Frame of reference, D. Kinetic energy. Number 8. An example of balance forces is A. A person is skating back and forth on an ice rink. B. A tire with treads gaining speed on an icy road. C. Two soccer players running in opposite directions. D. A book resting on a desk. Number 9. A force that sets an object into motion is A. Balance, B. Friction, C. Unbalance, D. Inertia. Number 10. Velocity is a measure of speed that takes into account sa A. Weight of an object, B. Force of the movement, C. Direction of movement, D. Acceleration of an object. Thank you, kids, and have a good day. I am Teacher Lani.